Hey, my name is Knackname, and several years ago now, I started a tutorial series on how to make kind of a randomly generating dungeon in Clickteam Fusion 2.5. And I never finished it. In fact, I only ever made one video, so not much of a series. But you know what? I figured today's the day. I'm going to go finish it. There are several reasons why I never ended up finishing it that I'll get into in a second. But just to start out with, we can take a look at this. This is what we are going to be making, and let's see if I can find a better example, but it's good enough. What this is a series of rectangular rooms, and they are connected by linear paths, just like that. And that's a good example. I like this one. So yep, room here, room there, this is probably a room as well, all connected up. So you can access everything, and I can walk around on this little green dude, and I can I'm holding down the key, I'm not going through the wall. Perfect. Before we get into setup, let's talk about one thing, which is I don't think you should follow this tutorial. It's kind of weird to say. One of the reasons why I never finished it is because shortly after, I just stopped using Clickteam Fusion altogether. Clickteam Fusion is a great tool. I think it's probably one of the best ways to learn like the grammar of programming. And it's really great if you want to make something that's kind of static, right? Something where, hey, I can set up my level and I can say, oh, all my enemies are here and all these things are there, and I can just build it together. But if you want to get into procedural generation or just anything that requires like a lot of data management, I don't think that Clickteam Fusion is the right tool for that job. If you're at the point where you're using Clickteam Fusion, you're kind of making your own thing, you're not just kind of using their own pre-built in stuff, and you want to kind of expand past that, you want to make something like a generating dungeon, what I would actually recommend is starting to take a look at a more standard programming language, C, C++, Lua, C Sharp, you name it, and then working with either an engine, like you could do Godot, or you could do Unity if you really want to do Unity, or you could get yourself just a graphic library. Like, I think my first graphics library that I used after Clickteam Fusion was Allegro with C. Now, I do not recommend using that one. That was just because I was learning the C language at the time. Just the easiest thing that's just a library, SFML. Otherwise, I'd say go with Godot and do C Sharp. And again, the big reason is because you're working with data structures. If you're making something super complex, it'd be really nice to, hey, we can make like a tree, and we can make like a map, and we can do all kinds of fun things, and we can make a super cool, complicated dungeon. And Clickteam Fusions doesn't have a lot of options for that. Now, they have array objects, they have list objects, but that's kind of it. Anything more complicated, you would kind of have to make yourself by making like new instances of objects and working with IDs, and it would be much better, and I think it would be much more valuable to you to just learn, C Sharp, get it in Godot, and do that. So step number one, do not follow the tutorial, turn it off right now, stop listening. But if you really want to, or you're just kind of interested in how you could do this in Clickteam Fusion, we'll go ahead and start now, and I'll go over all the steps. The very first thing that I have here is just these three. Now, these are all active objects. My first one I'll talk about here is the constants. My constants I have here, there are 11 of them. They're constant values, so these will not be edited at any time during runtime. These are only so I can reference them. We have our maze tile width and height. That's just in pixels, the size of one tile in our maze. It's also the size of this tile placer object right here, and we'll talk about that in a second. We have wall tile ID, floor tile ID, and hall tile ID, which is 12, 13, and 14. Now, if you open up your animation editor right here, and you take a look, if you have show all checked, we have all of these options that are added by default by Clickteam, and we're not using any of them. Actually, in a previous attempt at recording this, I actually discovered, hey, you can actually delete these, but if you don't delete them, then you would just need to add extra ones at the end, which you right click, you hit new, and you can make and name it whatever you want. In my case, this is the 12th, 13th, and 14th animation. If you go and delete all these default ones, you could actually have just the first, second, and third one, and you could have different IDs in there. But the whole point is that can I go here? No, I can't here. Point is that these match up with that. That's why they're there. And if we take another quick look here, all of these textures, what I have is all these rotated directions of the texture. I have just slight variations of it. This is how I chose to implement texture variation, and I'll show you how to do it when we get into the editor. Of course, there are a million other ways you could do this, but if you're following along exactly, then you'll want to have just slightly different variations. And we have that for the floor, and we have it for the hull. I just made 4 of them. In fact, I think I only made like 1 or 2 for the... Yeah, I didn't even do that many here for that. That's okay. Continuing on, we have our maxes and mins. This is for the room count, min and max. This is the number of rooms that we're going to generate in the dungeon. And then we have, right here, we have the room size, min and max. So I have it between 3 and 7. That's the number of tiles that will comprise a single room. So the smallest room will be 3 by 3. The biggest one is 7 by 7 because I put 3 and 7 there. You can put whatever you want as long as it works within your math. So, it could be a 3 by 3 room. I could have a 3 by 6 room. I could have a 4 by 5, whatever. That's what we're working with. And that's it for these ones. In fact, I don't need these at all. Get out of here. Let's talk about the tile placer next. My tile placer has these 10 variables, and they are going to be used later on when we work with our event editor. Their current values are all 0, not because they need to be 0, but because they're effectively unset. I'm going to be setting them when we get later on. Again, if you're following along exactly, just go ahead and make all these variables, and I'll talk about what they are and what they're doing a little bit later. Here we have our player character. They have 3 variables. They have a maze position, X and Y. So this is not their position on screen in pixels. This is their position within the grid. So, this could be 0, 0. This is 1, 1. This could be 1, 2. All depends. Then we have speed. Go ahead and set speed to whatever you want. And we'll talk about that again when we get to it. I put an underscore under speed. I don't remember why I did that. It has actually been months and months and months since I wrote this. But you can choose to do that if you so desire. We also have one flag, which is moving. And again, I'll talk about that in a little bit. Let's get to our data. Here is the floor data. This is going to hold the ID of every tile in the dungeon. And a couple important things to note. My X and Y dimension, I set it to be 40 by 22 tiles because that's how many fit on my size of my screen, which is 128 by 704. Again, you could do something else. Arrays in Clickteam Fusion are expandable, so if you try to access a value outside those bounds, outside of the 40 by 22, it will just expand the array to accommodate. We need to make sure that it is a number array. And sorry, I got a little bit sidetracked. It'll expand the array to accommodate, so if you want a dynamically sized maze, like, sometimes I want my array to be super small, sometimes I want it to be huge, then you can do that, but I'm not going to be covering that in this video. We are using a number array because we're going to be storing some numbers in it. I am doing a base 0 index. You could do base 1, but again, your code's going to be a little bit different. And in most programming languages, base 0 is what you do. That's what you go with. And that should be everything. Just going to flash these just in case something is different and you notice it. That should be fine. Then we have these three list objects, right? If we go here, actually go to list, we have that. Now, a list in Clickteam Fusion is actually something with like a UI component, it displays things in the list to the user. We're not going to be doing anything with that fact of it. We are going to be using just as data. So I have all of these marked as we're not showing them at start. Where is it? Where is it at? We're hiding it at start. We're not going to be using it. And again, this is the point where it's like, well, it's kind of weird and clunky, right? We have to use this thing that has like UI components to it, but we're just using it as a data structure. And that would not be even remotely the case in basically anything else other than Clickteam Fusion. There's nothing special about this. There are no variables. There's nothing about it. Except maybe, do I need to set it? Nope, that's all good. There's nothing about them. We just need 4 of them. We need one for height, width, X, and Y, which will be aspects of our rooms, right? We should have everything we need, so let's hop over here to the event editor. One thing that I'm going to cover briefly and that we're going to use all the time in this code is the idea of functions. Now, functions are commonplace in other languages, and in Clickteam Fusion's pseudocode system here, we really replace a function with a fast loop. If you're not familiar with fast loops, it's over here in our special conditions. We can go here, we can say fast loops, start a loop, and we can say, test. We're going to start, and if I spelt it right, there we go, test. We're going to start loop test 5 times. And that means that if I go here and I insert a new event, I could say on loop test. If I put that right there, then whatever is in here will get triggered 5 times because we're starting the loop test 5 times. Now, let's go ahead and just delete that. That was just an example. So that's cool. That's a way that we can create a section of events, or like a section of code, that we can call, whenever we need to use it. It becomes like a tool in our toolbox for when we want to generate a maze. And another important idea of functions is, again, most programming language, when you call a function, you also give it some input parameters. And that's what these are all going to be. So we've gone ahead and designated some IDs that will be like, hey, when we are going to call a function, and we have a function that says, hey, we're going to write a region. Well, we have our write region, we have our width, height, X, and Y. These are all the values that we're going to give to that function so it can do things with it in a kind of a generic kind of way. So we can have this one piece of code be multi-use, multifunctional. So right at the start of frame, and in fact, let's go ahead and comment out, or not comment out, but we're going to deactivate these things that we're not going to get to yet. Just our first statement, start of frame. We're going to start our loop generate maze 1 time. So we're going to call the generate maze function. Let's open that up. So generate maze will set all of the data of the maze. We're going to start by initializing everything to walls with using the write region loop. And let me actually comment all of these out. Sorry, wrong vocabulary. I'm going to deactivate these lines. So the first thing that we're going to do is set up our input parameters. So over here, on the first step, we're going to say, okay, we're going to set the placing ID, the region X, Y, the width and the height to some values. So the placing ID, we want to place everything with walls, right? We're going to initialize everything with walls. So we're going to set the placing ID value here to wall tile ID from our constants, right here. And we are going to set our write region, X and Y, so this is where we want to start our region. It's going to be 0, 0. And we're going to set the width and the height to the dimension of our array. Remember that I have my array. I remember it's a 40 by 22, so that's the values that we want to get. And we can do that by just going to our array right here and grabbing its x dimension, or its y dimension, or even the z dimension if you're using that. But I am not right here. So we set all the values of our input parameters, and now we are going to call our right region function. Now I have it written right here in this group, so we can open it up. Right region acts as a function to write an ID to a rectangular region of the array. Starting at right region x, right region y, the region exists to the bottom right. And that's all meaning that, let's say that this space, all these squares are positions in the array. It means that, hey, we're going to start at 0, 0, and if it's width 3, height 3, then every tile in this area is going to be set to the ID that we provided in this variable right here. The placing ID is going to be set to these positions in the array because it's 0, 3 by 3. So, very first thing we do is initialize the position in the array. There are other ways you could do this. Again, this is just what I chose to do. So set the dimension. So I can go here. I say like right. Actually, hang on. How do I set? There we go. So change the current position. We can set the x dimension index to our parameter, our input parameter. So we go here to our values, and we could set it to our right region x, for instance, of the tile placer. So we do that for both the x and for the y. Now, we're going to do some nested loops. So inside of this function, we are now going to call another fast loop. And we're going to say, okay, let's start our fast loop right region x, which consists of this and this and this. And we're going to start it the number of times as our, the number of times as our width. Now, because we set the width to the size of the array, and the array is 40, in this case, in this call of the right region function, it's going to be 40. So it's going to say, hey, start this 40 times. And right away, right off the bat, the very first thing we do is start another one. So immediately it's like, okay, now I'm in x, let's start the y loop height times. So 22 times in this specific call of the function. It's going to do it 22 times. And here's our game plan for it. When we write a region, we're going to say, okay, we're going to start here at the beginning. I'm going to jump into my x, then I'm going to jump right away into the y, like I showed that. And now in the y, I'm going to write the value to the array. So I'm going to say like, oh, I'm putting 12s everywhere in the array. So I'm going to be here. It's like, okay, where I'm at, I'm going to put a 12 there. Now I'm going to move to the next y position. I'm going to increase my y by 1, and I'm going to write the value. Then I'm going to do that again. Increase, right, all the way down until we get to the very end, and we've done that 22 times in this case. Once I've done that, I'm going to reset. So I'm going to go all the way back up to the top. I'm going to be done with my y's. I'm going to return to the x, and the x is going to say, okay, I've done the y. Now let's move on to the next position in the x. And it's going to go all the way down, and then we're going to reset and move, and go down, reset, move, all the way. And that's going to fill out the entire rectangle, depending on where we started, how wide we are, and how tall we are. So let's take a look at the actual code. We have this, we're in the y. Easy enough, we're going to write the value placing ID to the current position in the array. Right now we haven't moved at all, right? So it's still going to be at right region x, right region y, our very first position. Then we're going to move, we're going to say that we're going to add 1 to the y dimension index. So it's going to move to the next position. It's moving down 1. And that's it. These are the only two calls in Y. So it's going to do this, going to run these two things over and over and over again for 22 times. And it's going to write a value and move next, write a value, move next. And once it's done it 22 times, then we're going to continue to the next instruction in this right region X, which if we look, it's right here. So right here what we do is we're going to set the Y dimension index, just like we did over here. We're going to reset it back to that value. So we're resetting it to the right region Y. So it's going to move it back up to the top of the column. And then the next instruction is we are going to add 1 to the X dimension index. So like I said, do all the Y, move back to the top, move blah, 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 blah. Do all the Y, move back up to the top, move to the next X. So that will result in us visiting every single tile in our defined region. So let's close that out. So this particular call of right region is going to fill everything from 0, 0 to the width and height of our array with a wall tile. And if I click run, you see that nothing's happening. And that's because we're not drawing anything yet. So we've set all the data that we need, but we need to be able to see that data. So I'm going to take a break from generate maze, and we're going to go back up here and I'll activate this line. This line says we're going to start loop render one time. And render is another function that I don't give any input parameters, just kind of like generate maze. So I'm going to close generate maze and let's go over here to render and take a look at it. Now, this might look familiar. We start with render, we go to render X, we go to render Y, and back out to X. So this is very, very similar to right region. So let's take a look. On loop render, we're going to start by setting our XY position. This is our pixel XY position of the tile placer to 0, 0. So we're going to start it up in the upper left corner. And we're also going to set our dimension of our array to 0, 0. All right, starting everything at the beginning. Then we're going to start render X, the size of the array times. Again, that's going to be 40 because that's the size of the array. And immediately in X, the first thing we do is we just start up Y, dimension Y times, which will be 22 right there. Over here in render Y, the first thing we do is we go to our tile placer and say, hey, tile placer, we're going to change your animation sequence to the current value in the array. And what that's going to mean is because, you know, if it was a wall tile, the texture I have for that was animation 22. The ID for the tile also was 22. So we're going to set the animation, or excuse me, not 22, 12. So we're going to set the animation of this to be 12. So it's going to look like a wall. We're also going to set our direction to a random direction. If we take a look at this, if you don't know how to do random special conditions, we go over here to random number within range, and we give it a max and a min. I do 0 to 32 because that's the most directions that Clickteam's active objects will let you have. And I only have 4, but Clickteam is smart enough that it'll just round to the nearest direction that I have. After we've made the tile placer look how we want it to, we're going to just paste its image into the background. If you're doing something a little more complicated, you know, if you have like an animated texture or something like that, you may need to actually create a new object, but that's not what I'm doing here. So I'm just pasting the background, but just some thoughts in case you're doing something a little bit different. After that, we're going to set the Y position of the tile placer to its position plus the height of a tile, in this case 32. So we're going to move it by 1 tile in the grid. Then we are going to add 1 to the index of where we're at in the array. So we're just moving down. And that's it. That's it for our Y. And that will happen Y times. It'll go down, 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 paste, 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 until we have the whole column. Then, just like before, render X, move it in the X dimension by the width of a tile. Again, that's 32 in this case. You could have like rectangle tiles. That would work too. And add to the X dimension and reset the Y dimension. And then do it again, next column, next column, next column. And when we're done with all of that, what I do is I set the position off screen. This is just an arbitrary position, just so you can't see it anymore. That's it. So now that we have our render loop, and now that we've filled our array with data, if we run this again, you can see everything is wall tiles, back and forth. And this is kind of where we were at the end of that first tutorial video. But let's keep going. Let's go back here to our generate maze, because let's actually make the maze. Over here, let's reactivate these lines. Activate. There we go. So on loop generate maze, let's put some input parameters. It is going to be our room count. It will be our random, which we get from our special conditions, and it'll be between our minimum and our maximum room counts that we put in our constants. And once we've set that input parameter, we're going to call our make room function. So let's go down here and take a look at that. Open it up. So on loop make room, the very first thing we're going to do is we're going to make a new entry in all of these lists. Again, you could use an array, but I chose to use lists. We're going to add a new line. Just going to add a new entry into all of these. And the first thing we're going to do is figure out the size of the rooms. So the index, right? So this is going to say, okay, which member of the list are we doing? And we're going to grab the index of the loop. So you go to special conditions, fast loop, get loop index of make room. That will say that, hey, if this is the first time we ran in this chunk of saying, hey, we're going to run this, 10 times to make 10 rooms, I'm going to get 0, 1, 2, 3, 4. And we're setting it to a random between our max and our min, and we do that for both the width and the height. And just making sure I do everything, we're going to set line data. Right there. That's how we're doing that. We're setting line. Then, over here, we have to do something a little bit different. We're also going to be setting line data for our x and our y, but we have some considerations. All right, if we're making a room, then we want it to be within the walls, and I chose to have a one tile padding. So there's 1 tiles of walls all the way around the border. And so if we're going to do that, well, when we pick our starting position, we need to make sure it's not a 0, so we're going to start at 1. 1 will be our minimum for our x and our y. And then when we figure out the width and the height, well, we decided that, hey, our rooms could be like, is some size, right? It's 3 wide and maybe 7 tall. If we just pick a tile anywhere in here that isn't 1, then we could end up with our room being positioned right here. And this is within our bounds, right? But if we try to draw the full room, because we've defined it as being in the bottom right, it could end up going outside, and we do not want that. So what we're going to do is we're going to pick a random value between 1, 1 and between the size of the array. We're going to subtract 1, so we get that padding, and we're also going to subtract the size of the room that we generated. So no matter what, our room is always going to be within bounds. And taking a look here, that's exactly what we do. So again, we're going to get the position in the list. We want the position that is the index of our loop. We're going to have a random value between 1 and our size of our array, right? The dimension x of the array. You go here, x dimension, just like that. We subtract 1 for the padding, and then we're going to look up the value of our room's width. And you can do that by going to your list, room width. We're going to get line data. And the index that we're working with is the index of the loop, right? Because that's where we're setting the x, y. So then we can just grab that as well. So over here, we do fast loops, get loop index of make room. Mockway room. Perfect. So it'll do that. And that's what will get you there. Stick that right here. And we do that for the x and the y. Remember, the y is going to need to do the height, not the width. Over here in our make room, we are then going to set up our input parameters again, because we are going to be reusing our right region function right here. So instead of saying, hey, we're going to set it up so that every tile in the dungeon is going to be a wall, we're going to say that, hey, we're going to make some stuff into a floor tile. See the set placing ID to floor tile ID. We're going to set our x and our y to the values that we stored in our list. So just like before, we're going to look up the value in the list using the loop index. And we're going to say, get the x, the y, the width, and the height. And plug those into the x, y, width, and height of our function's parameters. And then we're going to call that function again. And it will work just like before. And if we do this, you know, a random number of times between 2 and 30, we then get this. A bunch of rectangles placed in the dungeon. All kinds of rectangles. Very good. Not the best shape, but it's a pretty decent shape. So now that we've done that, let's connect the rooms together. Go here, and I will activate these. So now we're going to call another function. Our function is going to be makePath. So I'll open that up, and we're going to call it room count -1 times. And we're doing that because if you have 2 rooms and you want to connect them together, you only need 1 room to connect them. So it's 1 less than the number of rooms. If you have 3 rooms, then you need 2 paths to connect them. You can implement it differently if you want. You can have extra paths or anything you want, but this is just what I am doing. So let's take a look at makePath. MakePath is a very small function, only 2 events. The first thing we're going to do is we're going to set, again, some parameters. We're going to set these parameters for not the right region, but the right path function that I'll take a look at in just a second. And we're just going to be setting our x1 and y1 of our right path. We're going to be setting it to our current loop index, and we're going to be using our current loop index to look up the x and the y position of the room from our lists here, just like before. We're also going to be setting our x2 and y2. And instead of just doing our loop index, we're going to do our loop index +1. So we're going to connect room 0 and 1 together, right? So it's 0 and 0 plus 1, which is 1. Then we're going to connect room 1 and 2 together. So it will be room 1 and room 2. Then it'll be 2 and 3, 3 and 4, 4 and 5, until we've got them all, right? Until it's been 1 less than the number of rooms that we have. So we're going to do that, and we're going to never go out of index, right? Because it's 1 less. So we set all that up, and we also set our placing ID to floor tile ID. I'm actually going to change that. Instead of floor tile, I'll do hall tile ID, just so we can clearly see what is a room and what was placed there from a path. Now, I think it looks better if the halls and the rooms look the same, but this is just for demonstration purposes. Over here in makePath, we'll now call our right path function 1 time. Because remember, we started this a lot of times. This only needs to do it 1 time. So let's close, and let's do right path. Now, right path is going to need a little bit of explanation. So to start off with, we're going to set the x and y position of our array to our input x1, y1. All right, so it's going to set the array. Then we are going to start our loop write path x one time, only one time, and I'll talk about that. Over here in write path x, we are going to write the value of our placing ID to the current array position, just like when we're doing the region. And now we need to move to the next position. So over here, we'll say like, okay, if our current position, all right, if our current index is less than, or better way to say this, if the target position for x2, because we're starting at x1, we're going to x2, is bigger than our current position, then we are going to increase our position, and we're going to restart our write path x. So it's going to jump back here, it's going to place down the ID again, and then it will check again. And if it's still too small, we're going to jump back up, write it again, do it again, over and over and over again, until we reach our destination. Then we can do the exact opposite. If we are too big, in fact, then we subtract one, and we go back, and we subtract when we go back until we have written all the way until we've reached x2. Now this is an idea called recursion, where this write path x loop is calling itself, it's calling itself, it's calling itself. And we have an exit condition, which is when neither of these are true and it doesn't call itself again. So if our position is equal to x2, then neither of these will trigger and we will exit the loop. If you are doing exactly what I'm doing, where it's saying that, hey, we're just gonna write everything in the x and then we're gonna write everything in the y, which a bit of a spoilers, but I won't cover this entirely, but this y is the exact same as the x. We're just doing it in the y dimension. But if you're doing this, I would not write your function this way. I would say instead, just do a little bit of math. So instead of writing the loop instead of starting the loop one time, we can do, hey, let's find the difference between x and y, right? And then we'll do it that many times. And if it is a negative number, then we'll go in the other direction, right? So you'd have 4 different cases. Either we're going to go this way, we're going to go that way, we're going to go up, or we're going to go down. Left, right, up, or down. That's what I would do. But I did it like this to kind of, talk about recursion and the idea of recursion in functions, which is a good thing to learn. But also, if you want to do something a little wonky with your paths, like if I say that, hey, I want my path not to be this exact right angle, surgical precision. I want it to like kind of meander a little bit, right? I want there to be like a chance that it goes the wrong way and then eventually goes back to where it needs to be. Well, then we wouldn't know the exact number of tiles that we're writing down. And so this is good if you don't know the exact amount of tiles. So we have the x. Then once the x is done, we're continuing on with our write path. And it's going to just do the same thing in the y, and that's it. We're all done. So write path, make path, done with that, and let's take a look. So if you're following exactly along, you should have something like this. We can see that these lighter tiles are the tiles that are part of the paths, and these ones are part of that. So let's do a couple more, and we can see how that looks. It's all nice. And just because I look, blah, 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 blah. Just because I think it looks better, let's change this back to floor tile. Awesome. There we go. And that's pretty much it. It's a very simple maze, a very simple dungeon. But let's wrap up the last few things that we need. We're going to put the player inside the first room. Super easy. We're just going to set our maze position of our player to the position of the room at the 0th index in the list. So again, just grab your list, look up the data. we're going to get 0. And because our rooms could be placed anywhere, that's just going to effectively put your player in a random room. It'll be the 0th room, but since all the rooms are random spots, it's just going to be random on the screen. And then we'll actually set the pixel position of it. And we'll set the position of the player to that maze position times the width or the height, respectively, if you're doing the Y, of a tile, which we have in our constants. We can just look up. Perfect. So running it one more time, our player is now inside the maze. And we can do it. There we are. That's where the first room was. And they're always in the maze somewhere. Perfect. And that is mostly it. This last bit is optional and just an excuse for me to talk a little bit. So if we reactivate, right here I'm destroying all the lists because we're done with them. I don't need them. Now if you want to, on the same frame, regenerate the maze for some reason, if you want to say that, hey, some of these rooms have different properties and different ideas, and you want to keep track of where the rooms themselves actually are, then don't delete them. You can have that data and store it for later use, and you can think about that later. Perfect. So now we have everything. This last start of frame, if I activate that, that again is just destroying the tile placer. Don't do that if you want to regenerate the dungeon, but I'm not going to in this example, so I'm just going to destroy it. Let's close that out. And the very last thing to talk about is the player. Now these are a little bit of chunky event triggers, so I can talk about that in a second. One thing to think about when you have a player is its speed. So a lot of times it's like, oh, we'll have our speed be 2, and then whenever we're moving, we'll just add 2 to the position of our player, all right? You can do that, but then you have an issue if your tile is not, if your speed is not a factor of the size of a tile, then you can never get exactly to the right position. So to fix that and to allow us to have any speed value here, we're once again going to be using some fast loops. So let's talk about our beginning movement. So we're going to repeat while the left arrow is pressed. All right. We're going to say that as long as our moving flag is off, and we'll talk about that a little bit more in a second, and as long as my maze position is greater than 0, so I'm going to say I can't go to 0, so I have to stay within the bounds of those walls, even if there's no walls there. I'm going to say that I can't leave, right? And that's just kind of a precaution. If you are guaranteeing that your tile and that your dungeon is going to generate like that, you could omit that if you wanted. Then we're going to look at this, and we'll say that, hey, if the wall tile is not the tile that we're moving to. So we'll look up in our array. We're going to read a value from our XY position right here from our floor data. And our XY position will be the maze position of our player. And because we're seeing if we can move to the left, we're going to say our X position -1. So it'll be the tile to the left. We're going to check that. And we're only going to allow ourselves to move if it's not a wall tile. So that allows us to move on both the floor and the hall, even though those are different. Now, if you wanted to make a more complicated set of tile types, you know, I don't just have walls and floor, I have walls and floor and water tiles and lava. And I'm going to say I can only go on the water if my character has some swimming gear or something like that, or if they're a frog or whatever. If you want to do that, what you may want to do is make a function. So you could say that, hey, if I press left arrow, then I'm going to call this function, and this function is going to say, can my character walk on this tile? So it'll take input parameters of maybe the tile that you're going to, and the ID of like what type of character you are, or something like that. And it could say like, okay, if I'm a frog and it's water, then you're good, otherwise it's bad and you can't walk. And then you can decide if you're going to walk based on the output parameter. So we've only done input parameters, and output parameter would be very similar. Now I could go here and say this is called can, or I mean it's a Boolean actually, so you may want to do a flag instead, but I'll do it here just because. So like can walk, and you can make a function called can walk, and this could be the result. So if it's a 1, yes, you can walk. If it's a 0, no, you can't. All right, and you can read that as the output of your function. But we're not doing that. So enough of that tangent. We've decided that we're going to move to the left. All this is good. So we're going to set moving on, and we're going to subtract from our maze position x by 1. So we're going to move that way. And all of these various directions, up, right, down, and left, they're all handled the exact same way. Just make sure that you subtract from the right dimension. If you're going up and down, you're going to be either adding or subtracting from the y. Left or right, you're working with the x. So it's all the triggers. Let's take a look down here. This is an extra little step where we're going to say that, hey, if our position is ever not where we want it to be, if our target position, all right, if our XY position is different from our maze position times the width, then we're going to start moving, and we're going to start the loop player move. And we'll talk about that in just a second. And we'll do that the same over here, wherein we say that if our x or y is the same, right, rather than if it's different, then we're going to stop moving and we're going to stop the loop. Over here on our loop player move, what we do is say that if the x position is greater than our target position, right, which is going to be our position times the width, then we are going to set our position, which again, this position is going to be our pixel position, -1. And we're going to do the same thing in all the other directions. We're going to subtract 1, add 1, subtract 1, add 1 from our xy, depending on if we are too small or too big compared to our target position. And the nice thing about this is that we could set our speed to anything. So if you go back over here, I can move left, right, I can go down, I can go up. If I try to walk on a wall, I don't. And that's it. That should be just about everything for making this maze. Now again, if you want to mix this up, and I highly recommend you do, I don't think this is a very good maze generator or anything like that. You can play with all kinds of things. You could say that, hey, you know what, I always want it so that there's a circle in the middle, and I want my character to start in the middle of the circle. Well, at the end of your maze generation, you could manually just say, hey, I'm going to set all the values in my data array to be a floor tile. You could do that. You could say that, hey, you know, if I expand it, you could say that, hey, we'll make sure that the camera follows the player, and we can walk outside, we can increase the size of the array. There are all kinds of things you can do if you want to do it this way. Now, once again, going back to the beginning, right? I really think that it would benefit you, maybe if you're really familiar with Clickteam, what you could do is follow this tutorial, make the maze or the dungeon generator, make some tweaks to it, make it your own, and then what I would suggest you do is go grab Godot, go grab any other game engine, or graphics library, pick apart and try to think about, how can I do this in this script in this exact way? And you'll find that it's so much nicer, it's so much easier. And I really think that if you can get a grasp on that, it will benefit you and you will be a better programmer for it. But other than that, I think that about wraps this up. I probably will not be making any more Clickteam Fusion tutorials in the future. I could possibly be making some showcases of other projects that I'm doing, or I could make a tutorial on how to make this exact same thing, in Godot. If you'd be interested in that, let me know. But other than that, just thank you for watching. Let me know if you have any questions, and I'll possibly see you in a different video.